Welcome to Superhero Conversations, a podcast saga with innovation leaders who are at SuperNova, the #1 tech innovation event in Benelux. And in today's episode, I'm really excited to welcome Marsha Ivins, the retired NASA astronaut. Welcome, Marsha.
Thank you.
Marsha, I'm really excited for this conversation. As I told you previously, it's my first time talking to an astronaut. It's always been my dream to kind of visit space someday. So my first question is, what inspired you to pursue a career in space exploration?
I was a child of the 50s and 60s. And in the 60s, in the United States, we started human spaceflight. And we watched on our black and white TVs every time we launched a rocket and launched a man into space. And I watched in that 9-year amazing period how we went from never having been to space before to walking on the moon. And I thought, and I was a big reader of science fiction anyway, and I thought I would like to do that. Well, that's not a career that young children aspired to, whether they were boys or girls, but especially in that era, girls. And so I said, well, let's see, the astronauts are men. Okay, that's out. And they are military fighter pilots. And that's out. But I did learn to fly when I was 15, before I learned to drive, actually. They were engineers. And I thought, well, I'll go off to school and become an engineer. Well, that was not as accepted then in the 60s as it was. My guidance counselor in my high school said, you can't do that. You're a girl. And I said, watch me. So I did. And I got into college and I went through engineering school and I sent my letter to NASA saying I'm ready. And it was during a period now in the early 70s where we were laying off people in the aerospace industry and in government. Strangely, similar to 50 years ago, but for different reasons. But eventually I ended up as an engineer at NASA, because my goal at the time was to do anything I could involving space.
And how did you turn that dream and kind of that want that you wanted to become an astronaut? How did you overcome all of those barriers, and how did you turn that dream into reality?
I don't know. I think a lot of luck, a lot of timing. I was in the right place at the right time for the right set of conditions kind of thing. I don't discount that part in the success in doing that. Becoming an engineer was not hard. You just have to graduate engineering school and get a job. And I did. You have to not do poorly at the job. And I didn't do poorly. And then I applied when they started selecting astronauts for the space shuttle program in the mid-70s, late 70s, I applied and was rejected. And then I applied 2 years later and was rejected. And then I applied 4 years later when they made another call and was selected in that time. So as long as somebody said, you cannot do this because of a reason that I understood was legitimate, you can't because you're a girl. Okay, that's not legitimate. You can't because you have a medical problem. That is a legitimate answer. But I never got that. So I just kept coming back.
Yeah, wow. So kind of this persistence, I think this mentality of persisting and applying could not be only implemented at NASA. Whether you're applying to universities and get rejected, you can apply one more time. Whether you're applying for a job or doing a business, the same mentality goes hand in hand.
Well, like I said, in 1973, 1974, aerospace industry across the United States was not hiring anybody. I mean, I got rejected from 27 different companies that I applied for before I was accepted at a job at a pharmaceutical company as an engineer, which is where I was when NASA finally answered my letter.
And so you were selected and you got the letter of kind of acceptance. Talk me through how long is the preparation for a spaceflight mission, and what is the process like? And yeah, we can go all in depth.
Yeah. In my day, when we were flying the space shuttle, a space shuttle mission was a short duration. They started out as 4 days, 5 days, and they went up to maybe 2 weeks. So that, compared to how long people spend on the International Space Station today, was a very short period of time. And so a crew was assigned a year before a flight. But when you are selected as an astronaut, you go into a year of basic training, learning all of the systems of the spacecraft you're going to fly, whether it was the shuttle or the space station. And the space station now made up of components from, multiple nations. They don't only train in the United States, but they train in Russia and Japan and in various places in Europe and Canada. And, their training takes 4 years. Our training for shuttle took about a year or a year and a half. But when you are assigned to a flight, you go into training specifically for your flight, and then more specifically for the particular job that you'll do on the flight. So on shuttle, we were divided. There was the pilot and commander who did the launch and the landing. There was the flight engineer, which is what I was for a while, that assisted them. 2 people were trained to do spacewalks. 2 people were trained to operate the robot arm. And then everybody was trained in the particular mission that you were flying. For space station, they all do all of it. So everybody learns to do a spacewalk. Everybody learns to operate the robot arm. Everybody learns all of the modules. So it's quite extensive and busy.
Busy. So it has been a year you've been training. And what are your emotions when you hear the engine thrust and you understand that you're actually being lifted from the ground?
Well, if you've watched launches, sometimes you get strapped in and you don't launch. So you don't want to peak too soon, in getting excited. And even on the shuttle, engines lit in a series. So the main engines of the shuttle lit first, and then the 2 solid rocket motors lit. And we had actually a mission where the main engines lit and then shut down, so they didn't go. So you don't actually get excited until you've lifted off the launch pad, because you may not go that particular day. And then there are sort of milestones along the way. On the shuttle, in the first 2 minutes, if something went wrong, we would turn around and come back and land at the launch site. If something went wrong in the next 6.5 minutes, we would end up in Europe or someplace landing. It was only after 8.5 minutes on the shuttle when the main engines quit and there were no red lights flashing and no sirens going. Then you thought, okay, I have left the planet.
So 8.5 minutes of this kind of concentration, and then finally you're kind of breathing out. Whew.
Yeah, well, now you're breathing out without gravity, but there's a whole lot of things to check. Particularly if you're in the front, looking at the displays and the controls and all of that and checking things. And then there's some things you have to do right away and yada, yada. And the same on when they launch on a Dragon and when they launch on a Soyuz and any of those vehicles. It is only after it has been jointly determined by you on board and the ground that you are safe for flight and that you don't have to just come around and land again, around the Earth. Now you can take a moment and say, okay, I have left the planet. I am not there anymore. And so the first time you do that, it's kind of, I don't even know how to describe the feeling. I mean, I've left the planet. You don't get that feeling in an airplane. I've left the ground. Yeah, big deal. You're not going to land in 4 hours or 10 hours or whatever it is. I have left the planet is not something we're emotionally, genetically prepared for, I don't think. And you, sure enough, there it is down there, and now I'm floating. And now I have to learn, because there's no way to simulate this on a long term. I have to learn that if I let something go, there it goes. It's floated away, and I take my helmet off and off it goes. And so, you're sort of struggling almost like a newborn in trying to figure out how to maneuver around this while things are clicking and happening, and you've got to do your job. And it's, I don't know, it's hilarious. You just start laughing.
This is just amazing. Marsha, you gave a talk yesterday to many young, aspiring entrepreneurs about space flight, about the space exploration. And you mentioned one really interesting idea that when you are at the space station and you look down to Earth, you don't see the world's boundaries, you don't see the borders, and it's all one beautiful marble floating in vacuum. What is an idea that has sparked in your mind after you saw the white blue marble from the space?
You know, people ask that question a lot, and you're sort of going for having, what was your moment, you know, whether it was religious or emotional or whatever. And I actually didn't have one, but when I come back from that, and we were asked as active astronauts and even retired astronauts to give lectures about the experience literally all over the world. And the presentation that I showed last night and that I will show again today is basically the same one that I show every time. And I realized as I started doing this that no matter where I go in the world, no matter what country, religion, ethnicity, political beliefs, you know, any beliefs, people laugh at the same things. They ooh and ah at the same things. They ask the same questions. And that to me was my moment. A real realization of that people are the same, no matter where in the world you put them, basically at their core, hopefully, that they're the same.
And what excites you about space?
Well, remember, I grew up reading science fiction. So, and when I was a kid and we were going from nothing to the moon in 9 years, I was thinking, man, all the cool stuff is going to be done before I have the opportunity to actually participate in any of this. We will have gone to the moon and developed a, you know, whole base at the moon. We've gone to Mars, we've gone to Jupiter and Saturn, you know, and all those really cool planets. And I'm going to miss the cool stuff. Well, here I'm still waiting, you know, for that.
It's just, I mean, this is just perfect. I mean, when you look at all of the innovations, all of the exploration that has been done in space, is just amazing. We talked with an aerospace engineer yesterday, and he told how many of the innovations that we use today on Earth are actually being developed in space, for space. So I would ask you about the innovation and the exploration that you do inside space. What do you think is one thing that is quite overlooked, or that you think that people take for granted, that the space exploration has actually brought the humanity?
Well, space exploration is one of the big drivers, but really anything that you try to do that you have not done before, whether it is in space or in the oceans or in the atmosphere or you know, anywhere on land, when you try to do something that has not been done before, technically, and you have to develop the capability to do that, that capability then has spin-offs that are practical in life. People focus on the space program because we had to miniaturize things, we had to develop materials and processes and all sorts of things to send as little mass as we could, as safely as possible to protect the, you know, fragile pink fleshy parts, and take them to the moon. But you could say the same thing of deep sea exploration. You could say the same thing of developing wind turbines.
Yes.
Yeah. So I'm looking at them right now.
Yes.
And so when you try to do these hard things that have never been done before, you don't only develop the material and the processes, but you develop the mindset that lets you actually expand, what you've done before. And space just is a big driver for that.
So you think that, researching those kind of extreme harsh environments like deep water or space actually brings us the knowledge and the technology that we could implement on Earth? And why do you think that humanity should put more money, more effort into exploring what is beyond the Earth?
There are mixed opinions about whether we should go beyond Earth. If you think about the human race, from the beginning of time, we have been curious and explorers and always wanting to know what's over the next hill and what's across that next ocean and that kind of thing. And we've sort of done a good job here on Earth. Well, that's the next hill. That's the next ocean. And I think it's just something inherent in the human genome that says, well, what's out there? And not everybody believes that. I'm a firm believer in what's out there.
Nobody knows.
Well, nobody knows, but I think we should. I think we should.
And to all of the young and aspiring and motivated people listening to us that maybe have a dream of becoming an astronaut today, what is your advice that you would give to them?
I don't, well, keep trying. It is not easy for anybody in any country to do this. Most countries that have space programs, and there are dozens of them, have a very strict selection criteria for their career astronauts. And if that is a path not available to you, then there are the commercial ones, but you have to have a very deep pocket right now in order to participate in that kind of thing. And that, even though it says we're doing this for all people, it's a very tiny, slim minority of the population that can afford to pay their way into space. But I don't know the answer to that. If going into space is your goal, then try to find a route. If participating in spaceflight in some way is your goal, there are, besides the 80 countries in the world that have a space program, there are 10,000 or more companies that participate in some sort of space business. And I don't even know the number of universities and research institutes that are doing the basic core science that support that. So there's always a way to put your finger in that pie.
So, as from your story as well, you did not become initially the easiest path to becoming an astronaut is becoming a jet pilot. So it's, but you could also become an astronaut if you learn engineering and if you learn aerospace engineering. So I think that's really exciting. And maybe you could share your thoughts for all of the dreamers, for all of the next generation explorers that are listening to us now. The theme for SuperNova is Shoot for the Moon. So why do you think we should take into perspective the space exploration when forming the goals that are on Earth?
Back in the 60s, we shot for the moon and we actually hit it. I mean, we did it. And there are other countries that have shot for the moon and hit it also. Not with people yet, but I mean, the Chinese just landed something on the backside of the moon and sent a piece home. So find a route. If engineering is what you like, there are engineering paths in participating some way in spaceflight, whether it is human or exploratory. If you're a chemical engineer, or if you're a physicist or an astrophysicist or a medical person or bioengineering, whatever it is that you have an interest in, there is some application where it is being used in space. I had the opportunity to visit Redwire, which is a local company here. It's a US company. But they have a number of experiments on board space station right now, and one of them is a bioprocessor. They are printing biologic. They printed a knee meniscus, which is incredible. And back to your question about things that you do in space, why is it advantageous? There is actually a manufacturing application of no gravity. If you can reduce the gravity imposed effects like sedimentation and that kind of thing, then you can create something that is more pure as a product. And so there may be a manufacturing opportunity simply in low Earth orbit, where we improve the products that we have on Earth, a spinoff of the space program, by doing that processing. So pick the scientific, technical field that you are interested in, if that's what your interest is, and pursue it in some way. And I bet there is a link somewhere to space in there.
That's fantastic advice. What is your perspective on the future of space exploration? Maybe you could share something that excites you, some technology, some mission, some new innovation that you think will come from space or to space in the upcoming years.
If we want to go anywhere beyond our local neighborhood, Moon, maybe Mars, we need a rocket technology that is significantly different than what we have. For whatever people say about cutting edge technology today from commercial providers going to space, that's not actually true. We're using the same basic rocketry that we used 50-something years ago. That hasn't changed. And it's limited in its capability to take us anywhere. But there are technologies that should emerge, they're right on the edge, that will let you get there faster, which is significant, whether it is nuclear, whether it's ion engines. Solar isn't particularly great because the farther you get from the sun, the less effective they are. But the nuclear and the ion propulsions are very interesting things. And of course, if some young innovator out there would invent the warp drive, then we could really get out of town, and go someplace cool. But that kind of breakthrough, not improvement on old technology, but breakthrough to new technologies, is something that is significant. We are spending our time on space station trying to learn the physiological effects of being off Earth, away from gravity, in a radiation field for long durations, and how that affects the physiology and the emotional states and all the rest of that. If we can get there faster, you spend less time. But if we can find a way to protect against the radiation, which is significant and damaging, and how to provide materials along the way. How do we grow food? How do we purify the air that we breathe, scrub out the CO2s from that? How do we reprocess water? How do we make fuel? How do we, make clothes, clean clothes? All of those daily things that are accomplished right now by resupply, from sending them from the Earth. How do we figure out how to do that without the Earth? Those are all technologies that aren't even nibbled at yet. So there's a wide open field of cool stuff to be yet invented.
Mm-hmm. And what is your perspective on multiplanetary kind of exploration? Should our humanity, or will our humanity, move to another planet?
There's a train of thought that says for survival purposes, we would move to other planets, and just tons of science fiction stories about what we've done, and that kind of thing. Not all of them great.
Yes.
So I don't know. There's a lot of things happening on the Earth right now. It would be unfair to take to another planet, frankly, in my personal opinion. But I think, I don't know. I think we should expand and explore for the pure nature of exploration. And I'm not sure I'm the majority thought along those lines, but that's mine.
Fantastic. Marsha, I would ask you one question And if it's too controversial or too science fiction, then we can cut it out. But do you think there are aliens out there?
I think when you look at a night sky, and particularly when you look at a night sky from orbit without light pollution, or when you look at those telescope pictures that show billions and billions of galaxies in a tiny little point in the sky, to think, to have the hubris to think we are it alone, that is both narcissistic and depressing in my mind, you know? So surely I would think there would be someplace else. Now, there is a thought in the science fiction writing that when technologies develop the capability, civilizations develop the technologies, giving them the capability to self-destruct, they do. And as a result, they never get much farther than where we are right now today. So the ability to literally explore beyond your own sun never evolves because we have self-destructed by using those technological advances to wipe the planet out.
That's quite...
So that's, like I said, is a doom and gloom kind of way of looking at it. But maybe that's true. But again, back to the hubris that says all civilizations run the same way ours do. Ours does. And maybe that's not true. And maybe we have been visited and they've looked down and said, I don't think I want to stop there, and moved on. I mean, I don't know. I hope that there is other life out there. I hope it is so uniquely different. I hope that we have the capability to appreciate and learn and not fear and destroy things that we don't understand.
Marsha, maybe you could share the fact that you shared yesterday on stage, that if you hold a sand grain on your arm's length, and there will be how many galaxies?
So this was a picture that I showed taken from the Webb telescope.
Yes.
And it covers the piece of sky covered by a grain of sand held at arm's length. And in this picture, there's like a gazillion dots of light. And each dot of light is a galaxy, not a star. I mean, you look at that from that tiny point, and that's only what we can see with that telescope. And that telescope, because of the speed of light, is looking back into, billions of years in the past. That's what the galaxy, what the universe looked like then. And we're now just seeing it because of how long it takes the light to get to us. So, I mean, it breaks your brain to think about that.
It absolutely does. I was sitting in the audience and I was just thinking about all of the problems that we have on Earth now, and how in some way insignificant, but also super significant they are for our humanity. And this thought that they're, and these galaxies are they do they exist now, or they
existed when the light left them? Whether they exist now, who knows? I mean, we will know in 1,000 years or 10,000 years or wherever, when that light gets to us. I mean, it's just, I don't know, it's mind-blowing.
It is mind-blowing. I think these kind of thought experiments and this perspective expansion can really help us to form our opinions on Earth today, and hopefully to understand how precious a human life and a human civilization is.
Well, that, and then the flip side of that, how insignificant we are in the grand scheme of things.
Yes.
And the phrase, don't sweat the small stuff. If we could learn from that kind of feeling to stop sweating the small stuff and just get along, we would be much better off for it.
Marsha, thank you so much for this conversation. I would wrap it up with the last question, maybe the hardest one. Marsha, what is your dream?
When you sent me this question the first time, I told you, I'm an old person. We have nightmares now. It's not so much a dream. But if I were to to realize a dream, it would be that we actually do figure out how to not self-destruct and actually work together to do this hard thing, which is space exploration, as opposed to we do it and you do it and everybody else does it. We are much better together than we are individually. And if we could, my dream is we learn that that's true.
I think this is just a brilliant thought, and we can see it from the space station where different nationalities are all together in a smallest place possible, and they get along perfectly well.
They get along perfectly well because their lives depend on each other. And that is just the basic core of it. Whether I agree or disagree with your politics or your religion or whatever it is, it's not significant because my life depends on you and your life depends on me. And nobody talks about that. It's just a fact. And then you can do great things.
Marsha, let's end this conversation on such a beautiful, positive note. Thank you so much for doing the podcast, and good luck for your next talk.
Okay, thank you. Thank you for having me.
Thank you.